Welcome back. We're going to do some more trig graphing today. And so what we're going to actually do today is we're going to look at the trig graphs. So trig graphing. And today we're going to look at trig graphing of cosine. Okay. So yesterday we spent time looking at sine graphs. And so just as a refresher, we're going to do a really quick review of a sine graph. So as review, let us graph y equals 4 sine of 2x minus 80 plus 1. Okay, so we're going to graph that. So go ahead, pause the video, give a really quick graph of that, and then come on back and check and see how you've done. Okay, so we look at this and we have to list all the things we're interested in. Remember, there are 4 things that we're going to calculate. It's going to be amplitude, it's going to be period length, it's going to be center line, and it's going to be phase shift. Those are the 4 things that we're going to keep track of when we're graphing a trig function. So the amplitude, remember, comes from the number out front, the a value. So the amplitude in this case is 4. The period length, well, the period length is always going to be, for what we're going to graph, 360 is the natural period length. So 360 is what it would be if it didn't have any transformations. But we're going to take the 360 and we're going to divide it by the number in front of the x that's inside the brackets. We're going to divide it by 2. So it's going to be 180 degrees. Okay, and then the center line is always the number hanging off the back. So it's +1 or just 1. It's the phase shift that is the most challenging. And the phase shift, the way that we're going to do it, remember, is we're going to take the entire set of brackets here. Didn't grab my color. The entire set of brackets, and we're going to set it equal to 0 and solve. So I'm going to say my phase shift is going to be 2x minus 80 equals 0. Pop that over. We're going to get 2x equals 80. Divide both sides by 2. Divide by 2. We're going to get x is equal to 40 degrees. So that's my phase shift. The phase shift is 40 degrees. So when we go to graph these things, okay, we're going to draw our axes on here. Now, I know that this thing is going to be shifted up 1 and to the right. So I'm going to want to have a little bit more room above the x-axis than below. But, again, it's not really all that big a deal. So first thing I'm going to label on here, I'm going to label the center line. The center line is at, we'll call that right there, 1. Okay. And then the amplitude says I can reach up 4 from 1. So up 4 is going to take me up to 5, and down 4 is going to take me down to -3. So it's going to provide some framing. So I'm going to go ahead and I'm going to draw in some framing here. So there's the upper end. There's the lower end, and I'm going to put in the center line as well because it just helps me when I go to graph these things. And then we're going to go back and we're going to say, all right, well, the phase shift, it shifted to the right 40 degrees. Remember, when we set the brackets equal to 0 and solve, the result is exactly what the phase shift is. So it's going to be to the right 40 degrees. So I'm going to come out here and just say, there is my 40 degree marker. Okay. Now, it's got a period length of 180 degrees. That means if it starts at 40, so here it is starting at 40, it's going to travel 180 degrees to complete it. So if it starts at 40, we add 180, it's going to take me to 220 degrees. So I'm going to come up here and say, all right, there's 220 degrees. And then it's going to go, because I want to sketch 2 phases of this, or 2 cycles of this, it's going to go another 180 degrees, because that's how long another one is. So 220 plus 180 is 400 degrees. Okay, so there, I'm going to go ahead and I'm going to put some framing in for these ones as well. Didn't grab the right color. Let's get rid of that and grab the right color here, or that color. All right, so here we go. Put that on. So there's a frame. There's a frame. And there's a frame. All right, so what we're going to have now is we're going to actually sketch this thing. Well, it's sine. So in general, sine starts from its midpoint, goes up, goes down, comes back up again. Okay, that's what sine in general looks like. It's positive because it doesn't say negative. So it's going to start from its center line, go upwards, come down, go to the bottom and come back up, and it's going to finish. So I'm going to mark the midpoint right here. I'm going to mark the midpoint right here. It just helps me form my graph. And I'm going to say, all right, it's got to go up, hit that, come back down, bump onto that, go up, hit that, come back down, bump into that, and then come back up. And there it is. There's our graph of y equals 4 sine of 2x minus 80 plus 1. Okay? So again, I want to emphasize, some kids think that it goes, it's more like this. It goes up and it's like a sawtooth and comes down and is a sawtooth. It's not, right? It is meant to be. It doesn't, I don't do a great job with it here. It's harder to do, but it's got to be curvy, right? So it's got to have curves to it. And that's what we're going to do. So there it is. There is a review of sine of x. So now we're going to look at the graph of y equals the cosine of x. And in fact, y equals cos x is extremely similar to y equals sine x. So I'm going to write the general form. So y equals a cosine of bx plus c plus d. Okay. All the same things, all the same things. A is still the amplitude. B still impacts the period length. D is still the center line. And the whole shoot and match of the brackets is still, we're going to calculate it the exact same way. That's where we're going to get our phase shift from. Okay, so this is pretty much identical to sine. The difference is what the parent function looks like, what it looks like before any transformations have happened. So I'm just going to go ahead and I'm going to sketch cosine in right here. So we know what sine looks like. We've done that a whole bunch. Cosine is quite similar. So this one would have an amplitude, because it doesn't show anything, but have an amplitude of 1. So I'm going to come up here and say, all right, amplitude is, got my shift on. The amplitude is 1. And then that means it's going to come down here to -1 as well. It has a period length of 360 degrees, because by default it has 360 degrees. So the period length is going to be equal to the 360 divided by this b value. Well, the b value in this case is 1. So 360 divided by 1, I'm going to write that out here. So 360 divided by 1 is, well, it's just 360. So this thing has a period length of 360 degrees. So if I want to sketch, actually I'm going to sketch just one of them in, just for clarity. All right, so then that's going to be 360 degrees to finish one full period length. I'm going to add some framing in here just to make my life a little bit easier again. Didn't grab the right color again. Oop, here we go. So there it is there. There it is there. And this is just going to be one period length, so I'm just going to draw in one frame. Okay. Now, if this was sine, so maybe I'm going to go ahead, I'm going to sketch sine in here. So if we did y equals the sine of x. So sine of x is going to be in whatever color this is. So sine, we know, starts at the midpoint, goes up, bumps into the top, comes back down, goes through the midpoint, comes down, bumps into the bottom, and then comes back up. There's sine, right? That is sine. Let's do cosine. I'm going to do cosine in, I think that's red. Cosine, instead of starting from the midpoint, cosine starts from the maximum. And then it goes all the way down to the bottom. And then it goes all the way back up to the top. Okay, and what it does is it crosses through in the kind of the quarter markers. So if we broke this up into 1, 2, 3, 4 chunks, each quarter. So cosine starts at the top. It's supposed to be curvy. It's, again, I'm not doing a great job of reflecting that curve, but curvy. Oh goodness. Come down, touches that. Curves, curves. So it's almost the exact same thing as sine. And in fact, if we took sine and we shifted it that direction, we'd end up getting cosine. So they're the exact same, just instead of starting at the center line, it starts at its maximum. Okay, so that is y equals the cosine of x. So let's look at a couple of example graphs. And the transformations are all identical to what we do with sine. Okay, so here comes some transformations. So I'd like you to try and graph. How about you try and graph y equals, we'll go start easy. How about 5 cosine, and we'll just do of 3x, and then plus 2. So go ahead, sketch that. Again, I'm going to want you to list out amplitude. I'm going to want you to list out period length. I'm going to want you to list out center line. And I'm going to want you to list out what the phase shift is. Okay. So in this case, amplitude is 5. Easy peasy. Period length. It's always 360 divided by the B value. The B value is 3. So the period length in this case is 120 degrees. Center line. Center line is the D value. It's what's hanging off the back. So it is going to be just straight up 2. Phase shift. Phase shift is always, we're going to take the whole set of brackets, set it equal to 0, and solve. Right now, in this case, it's not going to be very interesting. If I set 3x equal to 0 and I solve, I divide by 3, I divide by 3, we're going to say, oh, that just means that x is equal to 0. So it means there is no phase shift. Okay, so we're going to go ahead and we are going to sketch this thing. So it starts out the exact same way. Drawing my axes. Okay, I have a center line at 2. So I'm going to come up here and say, all right, there's my center line. It's at 2. It's got an amplitude of 5. So I can reach up 5 from 2. Up 5 from 2 takes me to 7. We're going to go down 5 from 2. Down 5 from 2 takes me to -3. Okay. And so I'm going to sketch in my framers here. Here we go. And then here we go. And I'm going to put mine on the center line as well, just to make my life, oh, that's not straight. Let's try that again. There we go. Now, we have to worry about phase shift. Well, there is no phase shift. So it starts right at 0. It's got a period length of 120 degrees. So I want to sketch 2 period lengths on here. So there's 120 degrees. It goes again, and it goes out. Double that is going to be 240 degrees. Okay, so I'm going to put in my framers. So there's one, and there's one. Now we're going to actually sketch this thing. Because it is cosine, I'm going to start at the max. I'm going to go all the way down to the min and then get all the way back to the max inside of the framing window. So I'm going to kind of find my midpoint. There it is. And obviously I'm going to have to come back up to here, and we're going to start here. And I'm going to get all the way down here for this midpoint, and then all the way up here for this max. And then I'm going to mark in the quarters, because the quarters are going to show me where it is that I'm supposed to cross that center line. Okay, so we're going to try and do it smoothly. It's going to go, it's going to curve down. It's going to curve again here. Now it's not very curvy, but curve up here. And here we go. Okay, so there is cosine. Now, imagine that it was sine. So if we had the exact same sine graph, y equals 5 sine of 3x plus 2. Everything about the framing would be identical, right? So the amplitude's the same, the period length's the same, the center line's the same, and the phase shift is the same. The only thing that differs between cosine and sine is where it starts from. Sine starts from the middle, cosine starts from the top. So if I were going to do this for sine, I'd want to mark the midpoint, and I'd want to mark the midpoint. And then I would say, all right, sine just goes like this. And it comes back down, comes up, goes down, and then comes back up again. Okay, so the difference between graphing sine and cosine is negligible. It's a very, very small difference. It is simply that cosine starts at its max and sine starts at its midpoint. Now, I want to visit, and let's do, how about we mix it up a little teeny bit, and we do, how about if we had y equals -7 cosine of 1/2 x plus 30 plus 2. Okay, so I'm going to go through the same process again. I'm going to say, all right, what's the amplitude? Now, amplitude is how far from the center line we can get. The negative, it's important. The negative is going to have a big impact, but this amplitude, strictly speaking, is how far we can get. We can get 7 away, so the amplitude is positive 7. We're going to think about period length. We're going to do period length is always 360 divided by the number in front of the x, the b value. So I'm going to do 360 divided by half. Break out your calculator if you need to. It is 720 degrees. Center line is just the number hanging off the back. In this case, it's 2. And then the phase shift. The phase shift is always the more challenging one. We're going to take the phase shift. We're going to take the whole set of brackets, set it equal to 0, and solve. So we're going to have 1/2 x plus 30 equals 0. Pop the 30 over. We're going to get 1/2 x equals negative 30. And then I'm going to divide by a half, and we're going to get that x is equal to negative 60 degrees. So that means it is shifted to the left 60 degrees. So I'm going to come back here and we're going to now sketch this thing. The framing starts out all the exact same again. So I'm going to go ahead, I'm going to draw on my axes. I'm going to have more room to the left of my y-axis than I normally do because it's shifted to the left 60 degrees. And it's also shifted up. So here we go. There are my axes. Now, start labeling some stuff. Center line is at 2. So I'm going to come up here and say, all right, there's my center line at 2. I can reach up 7. Up 7 from 2 takes me up to 9. Down 7 from 2 takes me down to negative 5. Okay, I'm going to draw in my framers. See if I can get it fairly close. Okay, well, close. So there's my upper framer. There is my central framer. And there is my base framer. Okay. Now, got my horizontal frames in. Now I'm going to worry about my verticals. Now, this says to the left 60 degrees. So I'm going to come over here and say, all right, there is about 60 degrees. Now, we've got a period length of 720 degrees. So that means if I were to start at 0, it would take me out to 720. But I'm not going to start at 0. I'm going to start at negative 60. So I'm going to take negative 60 and I'm going to add 720 degrees to it. So 720 plus negative 60 or minus 60 is going to take me to, I guess that would be 660 degrees. So my first period length is going to finish out here, and it's not drawn to scale clearly, is 660 degrees. And then it's going to go another 720 degrees to get out to our next one. So I'm going to take 660 and I'm going to add 720 to it. And that's going to take me to, I guess, get rid of that, 1380 degrees. So out here to 1380 degrees. So go ahead, put my new framers in for that one as well. So there's one, there's one, and there's one. So there are my framers, right? Now, I need to actually sketch this thing. And this is actually the easy part. After we have the framing done, the rest of it's pretty easy. It is cosine. So cosine, I normally think, I'm always thinking cosine starts at its top, goes down, and goes up. That is for a positive cosine. And what we have here is a negative cosine. So what that impact has is instead of starting at the top, it starts at the bottom. And it goes like this. So I'm going to start down here. I have to finish one complete cycle and get back down to here. And then one complete cycle and get back down to here. So I'm going to find the midpoint. There it is. Find the midpoint. There it is. And I'm going to actually go ahead and I'm going to sketch this as best I can, which is admittedly not great. Here we go. Comes back down. Bounces there. Goes back up. Bounces on. Comes back down. And there we go. What we have now is we have actually accurately graphed negative 7 cosine of 1/2 x plus 30 plus 2. And there it is. So cosine and sine are extremely similar in how we graph them. It is just where cosine begins versus where sine begins, and everything else is the same. So I'm going to give you a few questions here that you can try for practice, and then that will be it for the week. And then coming back next week, we're going to look at some applications of this. We're going to look at some, if I were to give you a graph, if you could tell me what the equation was. Okay, so here's some ones I'd like you to try. So how about we do y equals 6 cosine of 4x minus 100 plus 2. And y equals negative 5 cosine of 3x plus 90 plus 1. And then y equals 7 cosine of, let's make it interesting, 1/3 x minus 20 plus 2. And then just to keep us honest, how about y equals 5 sine of 2x minus 100 plus 1. So there are some practical questions for you to practice. Give those a whirl, and we'll be back again next week.